All right, well, it's 8 o'clock in Eastern time on Wednesday evening, and I said I'd start at precisely at 8, so welcome to all of you. This is getting the most out of your TI-84 CE and TI SmartView emulator software. My name is Tom Reardon. Is at Fitch High School in Ohio for 35 years, Youngstown State University for 40 years part-time. For the last 13 years, senior math advisor for Texas Instruments. Been an awardee since 1997 from Ohio, and for the past 3 years until this past July, CPAM president, Council of Presidential Awardees in Mathematics. So if you add up all those years, I should probably be dead, but fortunately I'm not. So all materials, videos, PDFs, everything are available at this website. I will show you this several times, and I'll show you that website at the end. It is case sensitive. Lowercase bit.ly / and the rest are capitals, TI 2019 PAEMST. And again, I'll show you this later on, and I'll show you what's on there. This is being recorded, so if you're not able to stay for the whole thing, you'll be able to watch it at your leisure, and the link will be on that website as well. So first of all, congratulations again. I'm sure you're not tired of hearing that. You were in my home office in Columbus, Ohio. We've been here almost a year. I grew up and lived my entire life in Youngstown, Ohio area. So this is kind of new for me. If you have questions or comments, you can use the chat, but since there's so few of you, I'm okay if you just unmute and say, hey, Tom, could you do this? Or what about that? And so on. Very low key. Just want to make sure this is something you can use. So I always start off with a quote in the classroom, presentations, whatever. I'm convinced that students learn in more ways than I know how to teach. And that doesn't mean I've given up. It just means I'm aware that I haven't found all the ways yet. And this is from Stephen Reinhardt, who wrote an article around 2000, Never Say Anything a Kid Can Say. It's an excellent article if you have not read it. So I will give you a disclaimer here. Some of you are going to be irritated with me because I'm going too slow for you. I understand that. I apologize in advance. And some of you might say I'm going too fast for you. And again, I apologize. But the solution is that the website I'm going to give you will have links to this video, but also videos that you can watch and see a PDF with step-by-step on how to do these things. And I'll show you that in a little bit. But you'll have this one big video, but you'll also have another website that has little videos of some of these things I'm doing, and some of the things that I was not able to do because of time. You'll actually be able to see those as well. But again, since it's a small group, catch me as you need to. So this is the videos. A link will be to these videos. There are 16 of them here. And there'll be a video, and then there'll be the PDFs, okay, for each of those. So I'll explain that more a little bit later. We are going to be using the TI SmartView software that emulates the TI-84 and the CE graphing calculators. You can use this on any computer except for a Chromebook or on an interactive whiteboard like a smartboard, a touchscreen computer. And you can attach your 84 to your computer and run this off with the calculator, as I'll be doing sometime today too. So I'll be showing you how to use this software as well as how to use the calculator. And this is not just for newbies, and it's for people who've been using this for a long time. This is my favorite talk to do as I go around the country and talk to people. It's probably my best received one. And I have people who've been using a calculator for 20 years saying, I learned more than half of what you showed me. So hopefully this will be worthwhile for you. So we're going to start off. You can either do this along with me or just watch and then try to do it later. That's up to you. But I'd like to start off by evaluating the expression and do it in many different ways. So I'm going to bring up my emulator here. And this is the TI-84 SmartView emulator that you should have received the software for. If you didn't, we'll talk about that later, but you should have that. So to evaluate this, there's several ways, and I'm just going to start off with my least favorite way, and that is I'm just going to go ahead and type in 5, and store that in for X. So I typed the number 5, I pressed the stow key down here, and then I press the X key, and then I'm going to press enter, and now X has the value of 5. And then I'm going to do is I'm going to type this expression in and press enter, and it'll evaluate it with that number 5. So you'll notice it is a rational expression. To get a fraction, there's 2 ways to get a fraction. One way is to press alpha y equals, and let me make this a little bit bigger. Oh, sorry, I forgot I had that pumpkin on there. So alpha y equals, and this will pop up. These are all the fraction things. And the first one is to create a fraction. Okay. I'm going to clear that because on the newer calculator, the other way to get a fraction is to press alpha followed by the xt theta n key. Notice the last key I press is red. And so I get the fraction template or rational expression template there. And so I'm going to go ahead and type in the numerator, and that will be x, and then the squaring key minus 2, and then the X key. So there's the numerator. And it says to press the right arrow or the down arrow to get to the denominator. And the denominator was 3x plus 4. 3, the X key, plus, and then 4. And I'll let you get kind of caught up there because I type a lot faster than you probably do. And so the way this works is I stored 5 in for X. I type this expression. When I press enter, it's going to take the current value of X, substitute it in, and do all the calculations. So I'll go ahead and press enter now. And mine is a little bit covered up with some of your pictures, but we're getting 15/19. And we're getting a fraction instead of a decimal because I have it in fraction form, and there are no decimals anywhere in that fraction. Now, if I did want the decimal for that, alpha y equals is one place you can do that, and that's number 4. That's alpha y equals, which is green, y equals, F1 key is this. And if I press enter on number 4 or press the number 4, it says take my last answer and convert it to the other guy, which in this case is the decimal. If I press enter again, it'll go backwards. Okay, it'll take from decimal to fraction. So let me just stop there for a minute. Is that too fast, too slow? Again, you can unmute yourself and talk to me. I'm okay with that. There's only a few of you. All right, so so good. All right, got it.
I'm a little bit of a newbie with this, so.
Okay, so
that was the alpha, the X, the red key that you had before, right?
So the alpha and the key right next to it, that's where you get the fraction from, right? And we're going to do that again. So if you're behind, we'll just do it in a different way because this is my least favorite way to do that. Okay. So the second way is to, let's go to y equals, and let's clear what's in y equals. And in y1, I'm going to type that rational expression again. So again, I'm going to do alpha xt theta n to get the fraction template. Again, for those of you who don't have the newer calculator, you may have to press alpha y equals to get the fraction template, which is number 1. Okay, and so now again, I'm going to go ahead and type x and then squaring key, x key, and then the squaring key, minus 2x, and that's all in the numerator. Right arrow or down arrow takes me to the denominator, and my denominator was 3x plus 4. And then I'll press enter. And before you press enter, you should always double check and make sure it's right, because it's easier to edit when you're there than later. But so there's our y equals. And let me go ahead and pull that screenshot off. And this is my favorite feature, by the way, of the software, is that you can pull the screenshots off of the calculator into Word and PowerPoint, Smart Notebook, Google things. But I just left clicked on here and pulled that off. And this is one of my favorite things to do, okay? Because now when I'm often doing something ahead of this, the people who are behind can say, oh, that's where I need to be now, okay? All right, so we have that typed in. We'd like to graph it. So we're just going to go ahead and use a Zoom 6, which is Zoom standard, and go from there. So Zoom 6. And so I would suggest if I say Zoom 6, you type Zoom and then 6 and it will do it. When I do it though, I arrow down to it so you can see where I'm going and it slows me down. So let me go ahead and do a Zoom standard. And so it's graphing this rational expression. Some of you might have an asymptote there. Let me see if I can get the asymptote there as well. And if you don't have it, it's okay. But if you did have it, it would look something like this. And we'll talk about how you deal with that in a little bit. But right now you should have the graph. And what I want to do is trace to these numbers, okay? So I'm going to go ahead and press the trace button. And as I move left and right, you can see that the coordinates change. And it doesn't look like I'm ever going to get to the number 5. So I'm just going to go ahead and type the number 5 and watch what happens. As soon as I type 5, at the bottom of the screen, it says, this is what you want X to be equal to. You want X to be equal to 5 or 51 or whatever you want it to be. And then once you're done typing, just go ahead and press enter. And it takes you right to that value, okay? So here again, I just pressed trace. And then as I was moving along, I just typed the number 5 and pressed enter. And it took me there. Okay, somebody said they've already learned something new. Okay, well, that's a good thing because I hate to waste people's time. All right, let's go ahead and go back to trace. And this time I'm going to trace to -5. So I'll just type in -5 and it says X equals. And when I press enter, it takes me there. And you'll notice my answers are fractions because that's how I typed it in. And so I like that. I could change them to decimals, but I prefer those. And for those of you running behind, as long as you've traced on one number, that will be fine, okay? At least you've done one. So lastly, I'm going to go ahead and press trace, and I'm going to trace to -4/3. So -4 divided by 3 is another way to write -4/3. And when I press enter, I get, at first, what looks weird, I get the decimal because I did it as a division and not a fraction, but it tells me y is equal to, well, undefined, and doesn't surprise us because that would make the denominator 0. So we've just looked at how you can evaluate an expression using trace. And let me stop and see if there are any questions. Again, as long as you've done one of them, that's fine. If you did all 3, that's great. Any questions, comments?
You just said that was undefined when X was -4/3.
Right. Because when I put in -4/3 in the denominator, I'm going to get a 0. And that's why it was a blank. Instead of saying error, it's just a blank. Okay, good question. Let's try another different way. Let's go ahead and use a table. So go back and to get a table, the first thing you need to do when you do a table is set the table. And that's accomplished by pressing second followed by window. Second window, you can see in blue, it says table setup. Blue is second. So blue up here is table set. And let's start the table at, let's say, -5. Then arrow down. And let's have the table change every 1. And let's have both of these on automatic, independent and dependent on automatic. So if they aren't, go down to it and press enter on the word auto. So your table setup should look like this. Start at -5 and change every 1. Oh, you love this. Well, I'm glad this is good. This is good. All right. So once you have this, to get to the table, You'll notice tables in blue. So I'm going to press second graph to view the table. So second followed by graph. Oh, before I do that though, let me just go ahead and pull that off so that I have that there. Okay. Because what I'm going to do is I'm going to save a copy of these screenshots and also put that on the website so that you can go back and see these again. So now I'm going to go ahead and press second followed by graph to see the table. And let me pull that off so see it better. And I can see that at -5, it's -35/11. And I can see where it is for all these other values. Okay. And I can just go ahead and scroll to whatever numbers I want. And I can go to a +5 and see what it is at +5. Now, I'm not going to get -4/3, so I'm going to show you another way for -4/3. But this is using table, and it's a nice feature to have. And someone said they love the fraction is in the table, and that's because we create it as a fraction. If we would use the division sign and done it, it would have been a decimal, or if we would have had a decimal anywhere in the numerator or denominator, it would have been a decimal, okay? So let's go ahead and look at another way called table ask. And this is one that I really wish teachers knew more about because I think this is so powerful. So I'm going to go back to second window, that is table set, second window, table set. And I don't care where it starts or whatever, but go down to that independent where it says automatic, turn right and press enter on the word ask. So this is what we want here. Okay, we want independent ask. And again, it doesn't matter what these two are. Whatever they are is fine. This is the key right here, ask. Okay, so now when I'm going to go ahead and go to the table, second followed by graph. And first, some of you are going to say, well, that was a lot of help. Look, there's nothing there. Well, it's waiting for you to ask for the values you want. So I'm going to go ahead and type in -5 and press enter. And there's my answer as a fraction. +5. And then for the fraction here, if I press alpha xt theta n, or if you need alpha y equals to get to the fraction template, whatever works for you, but get the fraction template, and we can go ahead and type in -4 over 3 for -4/3. You can see we're getting an error because it is undefined there. But I could type in any numbers here, 3.1, 6. Okay, just type in whatever numbers we want, and it will go ahead and calculate it. And what I like about this is I don't have to worry about what my delta table is. I don't have to scroll a lot. I can evaluate expressions real quickly by having the table set, having the table with independent ask. All right, let me stop there for a minute. The person who's the newbie, are you able to keep up, or am I going too fast? Please let me know.
Doing okay. I'm a chemistry teacher, so.
Okay.
So
Okay.
it's taking me a little while to figure it out, but I'm doing good.
Okay, and keep in mind though, you can always go back and watch it again. I've got specific ones you can rewatch. I'll have specific ones, but if you get really lost, don't be afraid to speak up because we don't have that many people. We're doing okay. Love
Yeah,
tape.
no, good. Thank you.
Never knew about the ask. Okay. All right. So now that we've got this, let's go ahead. As much as I like table ask, I don't want it. So I'm going to go back to second table set, second window for table set. And I'm going to go back to automatic. Okay. So we're just going to go back so that it's not in that ask mode. And let's go to y equals just to double check what's there. So not surprisingly, that's what's there. Okay. This time, I'm sorry, I did goof. Back to table set, my goof. And let's start the table at -5 like we did before. And a delta table of 1. And these two are both automatic, okay? So this is the table setup that we want here. Only this time we're going to view the graph and the table at the same time, which I find really good for students who are just starting out, okay? And the place you get that is under mode and go down to full, which is about halfway down. Make a right turn at full and go over to graph table and make sure you press enter on graph table. Okay, so I started by pressing mode. This is the mode is like the least fun, but very essential part of the calculator. So we're changing the mode from a full screen to splitting between a graph and a table. Make sure you press enter. And I'm not gonna have you go to the graph. I'm gonna have you go to the table. So from here, press second graph. And what it's doing is you'll see it's showing you the point on the graph and showing the ordered pair in the table. And as I scroll down the values for the table, you can see where they are. And I just love this, that you can see the values and the ordered pairs and the points on the screen. And hopefully at least one of you like that too. So this is a graph table. Now, some people say, well, why don't you just trace? Well, let's try trace, see what happens. So press the trace key and you can see, yeah, I can trace here, but man, nobody's happy. I mean, those numbers are just awful. And the reason why we like the other way was I wasn't tracing on the graph. Remember, I told you to go to the table. So let's go back to that. It's easily fixed. Second graph takes you back to the table. And the reason that's nicer is we can set the table values, the delta table value here. On the graph, we really can't set that easily. So this is why I really like this feature here. All right, you would think I would be finished by now, but I have one more thing to share with you on that. And let me go ahead and pull that off. So we'll have a nice picture of that too. All right, the last one is using what I call function notation. So again, as much as I like graph table, when I don't want it, I don't want it, and I don't want it right now. So I'm going to go back to mode and go down to that full screen again and press enter on full screen because I don't want to see graph and table this time simultaneously. By the way, somebody may be wondering about horizontal. I find that to be useless. It doesn't work very well. So full screen. Let me pull that off. And now what we're going to do is go to the home screen. And the way you get to the home screen is by pressing second followed by mode because it's really quit. Second mode is quit. And let's press clear to clear that because it's kind of making me nervous there. And remember, our equation is in Y1. So on the home screen, I'm going to bring up Y1, and there are two places to get it. I'm going to show you the way I don't use anymore, because that's the way some of you might have done it. And don't go there. Vars, Y vars, function, there it is, okay? I'm not doing that anymore. The quicker way is to press alpha followed by trace, and that's where the Y variables live, and it's so much quicker to access them. Alpha followed by trace is the F4 key, and it has the Y values, and I'll just press 1 or enter to get Y1. And I want to evaluate that at -5, so we're going to use function notation. Left parentheses, negative sign, and not a minus sign, but the negative sign, okay, 5, and then right parentheses. And make sure your students understand that this means we're taking what's in Y1, replacing the variable X with -5, do all the calculations, press enter, and out comes that value that we've been getting. Now I can also evaluate this at any other number. We were asked to evaluate this at +5. Instead of doing it again, let's use the idea about going through the history. So I'll press the up arrow once and it goes to the history there. And I press it a second time and it takes me to this, and I've got this highlighted. If I press enter, it'll paste it down where I can edit it. So let me do that again. I pressed up arrow twice to highlight that, press enter to paste it down. And what I'd like to do is just get rid of that negative sign. So I'm going to move my cursor with my left arrow so it's sitting on top of the negative sign. Don't press clear, press delete. And now we can go ahead and press enter, and it'll evaluate it at +5. Okay. And then if I want to do the 4/3, again, I could do alpha trace and get the y1. Again, left parentheses because it's function notation. Alpha xt theta n gives me the fraction template. And I think I wanted -4/3, if I remember correctly, -4/3. And then notice I do the right arrow to get out from that denominator. Make sure you do that. You don't want to be stuck. If we put a parentheses in here, it's going to be weird. Okay, so get out from the denominator, right parentheses, and now it's going to evaluate y1 for that value. And it says error, dividing by 0. Okay, and if you weren't sure about it, we could actually go to it by pressing 2, and it'll show you there's a problem here. Okay, so again, if I would have just done this and just said, pressed enter and just said quit, then it just takes me back there. Okay. So this is using function notation. And again, I love this notation. And I think it's something that makes it much more valuable to us as teachers. All right. So questions, comments? If I'm going too fast, just say slow down. I even have to know who it is. Or if I'm going too slow. Okay. All right. So that was a lot with one example. Let's look at a couple other things here. Just right. Okay. Sounds good. All right. So now I'm going to go ahead and clear my home screen. Press clear. I'm going to go back to y equals. And this time what I want to do is evaluate functions. Let me get rid of that. I don't need that anymore. Get rid of that one. Oh, and this is just a reminder, quick path to the y variables, alpha followed by trace. Alpha followed by trace. Just reminding you on that. All right. So
Is that y1?
Yes.
Just getting that y1 using that alpha trace, does that work anytime you need y1? Like even
Yes.
when you're doing
Yes.
regression and you want to
Yes.
store the equation? Okay,
Anywhere.
that's so
anywhere.
much shorter.
Yes.
I love
yes.
that.
Yeah, I remember teaching my students a song. I would say vars, y vars, function, y1, you know, like you had to really think about it. Now it's all there. So glad you like it there. Okay, so let's go ahead and do some function evaluation. I'm going to go to y1. I'm going to press y equals. I'm going to clear what's there, clear that out, not delete it, but clear it. Okay. And what I'd like to do is put this in y1. 2x plus 1 will be my f function. It'll go in y1. So I'll type in 2x plus 1 and then enter. And y2 is going to have the g function 4 minus x squared. So 4 minus x squared, and press enter. And so this is what I now have in my y1 is f. My y2 has g. So now I want to evaluate f of g of -1. So I'm going to go off to the home screen by pressing second mode, which is quit the graph screen. And instead of f, I'm going to type y1. So again, where we get that as alpha trace is where we get the y variables, alpha followed by trace. I'll press 1 or enter to get y1. Left parentheses above the number 8. My g function is y in y2, so I need to press alpha trace. And now I can either press the number 2 or go down to 2 and press enter, your choice. Left parentheses, -1, and make sure you're using the negative sign. The negative sign is here. These are the binary add, subtract, multiply, and divide on the right parentheses. So this, and I need, I guess, a double right parentheses. So y1 of y2 of -1. And so I'll go ahead and press enter. And I'm getting the value 7, which I'm hoping is correct. So what I'd like you to do right now is I'd like you to now do f of g. I'm sorry, no, g of f of 3. G of f at 3. And I'll let you try that on your own. And then I'll talk you through it. All right, so some of you may be finished, some of you still working. So since I want G, that's Y2. So I need alpha trace to get the Y guys. I want the second one, Y2. So I'll press either 2 or arrow down to this and press enter. Left parentheses, and now I want Y1, alpha followed by trace. Y1 is either 1 or enter. Left parentheses 3, then double right parentheses. So that's G of f at 3. Press enter. And again, it evaluates that for us. So I'm not going to do the other examples. I think you can anticipate what they are, but I can do Y1 at 3 plus Y1 at 4. I can do Y2 of 2 divided by Y1 of 3. I mean, you can do all that function composition there. So, all right. This next one, I think for the science, I think one science person, the chemistry teacher, this I think will be a little bit more for you. Okay, I mean, for all of you, but the ideas behind this, I think will be some good things for you here. So one of the things that I want my students to be able to do is to be able to use the quadratic formula by hand. And once they do that, then I want them to be able to use it in the calculator, okay? And so I'm going to show you how you can store the quadratic formula into your calculator and have it there all the time, okay? All the time, okay? So to do this, I'm going to go to y equals. I'm going to clear those guys out. I don't need them anymore, y1 and y2. And you might recall that the I'm sure you recall, the quadratic formula. Let me is x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. So there's 2 parts to it. So when I put this in the calculator, I'm going to I need 2 separate lines, one for the plus, one for the minus. So I'm going to store them where I don't usually go, and that is in y9 and y0. So now that we're in y equals, I'd like you to clear those out and arrow down to get to y9. And I know some of you are uncomfortable because you've never been past maybe y3 before. And it's okay. It's really not scary down there. It's okay. So we're going to go down to y9 and we're going to type in this expression with just the plus sign. And that means I need the rational expression. So again, I'll use alpha xt theta n, or I can use alpha y equals and find the fraction template. But I really don't want to do division. I want to have a nice fraction template. So I need the opposite sign, not the minus sign, the opposite. And the letters are in green, and they start here with A, B, C, D, E, F, G, and so on. And so the letter here is alpha apps will get me the letter B. Alpha apps, alpha followed by apps get me the letter B. The plus sign. And then I need a square root, and the square root is above x squared. It's in blue. So second x squared gets me the radical sign. And, and underneath there, I need to type in the discriminant b squared minus 4ac. So again, I need alpha apps to get the letter B. I want to square that by pressing the squaring key. And I'm going to pause for a minute because I know I'm going too fast for somebody. So I start off by getting the fraction template, the opposite of b plus second x squared got me the radical sign. alpha apps got me the B and then the squaring key. I do need the minus sign, not the negative sign, because I'm subtracting. 4 alpha math to get A, alpha program to get C. And you'll notice that I'm still under the radical sign. And to get out from the radical sign, it says press the right arrow. So when I press the right arrow, it takes me from underneath the radical sign, but I'm still in the numerator. So I can either press the right arrow or the down arrow to get to the denominator. And that's going to have 2 alpha math for the letter A. Now, before you press enter, double check, triple check, make sure you have it exactly the way I have it here. Okay. If you do type it in wrong, I probably will just tell you to just do it later at another time. So just double check that and press enter. Now I have good news for you. Y0 is almost the same as Y9. So we're going to use the copy and paste feature that very few people seem to know, but I'm going to share that with you because I think you're going to love it. We're going to copy and paste Y9 and paste it into Y0 and then just change that 1 plus to a minus. Okay. Just out of curiosity, does anybody know how to copy and paste on an 84? I'm guessing no. So here's how you do that. You should be sitting in Y0. Okay. I want you to press the second key followed by the stow key for store, and you'll get the word recall for recall. So I was in Y0, I press second stow and recall pops up. And what I want to do is recall Y9. And that's where I again go to alpha trace. And I can either press the number 9 or arrow to it. If I press the number 9, it automatically brings it up. If I arrow to it, I have to press enter on it. And now when I press enter, it's going to paste whatever's in Y9 where I was, which was in Y0. And you're going to love it. At least I hope you're going to love it. So now all I need to do is change that plus to a minus sign. So I'm going to press the left arrow and up arrow until I can get over to that plus sign and sit on top of that plus sign and type a minus sign to go on top of it. I will explain copy and paste again. Yes. Okay. So hopefully those of you who did it correctly, that's what it looks like. I'm going to go ahead. Don't do this. Just press. I'm going to press clear. I'm going to do this again. Okay. So I'm sitting in Y0. I've already got Y9 there. I'm going to press second store, and the word recall pops up. And you can see in blue, it is recall. And then I'm going to use alpha trace to find the Y9 that I want. So what I want you to do is press the number 9 now, but I like to go slower. So I'm going to arrow to 9 and press enter. And it says, remember what's in Y9? Yep. Press enter and it will paste. And now all I need to do is arrow over and make that plus sign into a minus sign. And let me arrow up to get out of there so we can see that. So here's the quadratic formula. It's in my calculator. And it'll be there until I get rid of it. Okay. So let's go ahead and use this to solve this equation just to show you that it works. And I know this one I think is x equals 3 and x equals -2 are the solutions. Okay. So let me go off to the home screen. Second mode is quit. And I'm going to clear that so there's no stuff there. Okay. And I need to type in the values for A, B, and C. And you can see that here that A is 1, B is -1, C is -6. I need to store those values into those variables. So I'm going to type in 1 and the store key, alpha math, enter. And now A has the value 1 until I change it. Similarly, I'm going to type in -1, store into alpha apps, which is the letter B, because that's where they got the -1 right here. And -6, store alpha program, which is for C. So I just typed in the values of the A, B, and C. And now to evaluate this, remember where these are. These are in Y9 and Y0. So to evaluate it, again, I'm going back to alpha trace. And I want to evaluate Y9. So let's bring up Y9. And again, please remind your students, it's going to go to Y9 and replace all the values of the variables with their current values, do all the calculations, and hopefully it's going to come up with either 3 or -2. Good. And if it didn't, you typed it wrong, I'm sure you can fix it at another time. It works, it's just a typing thing. And then also I can go alpha trace and look at Y0 and evaluate Y0 with the current values, and it should be -2, and it is. So we're kind of thrilled. So we are going to do another one. So if it didn't work for you, please go back to your Y equals and make sure that they look exactly like this. Common mistakes are having negative signs where minus signs are, and minus signs where negative signs are, or not typing the variables in the right spots. So another thing I should probably point out, if you go back to Y equals, go down to Y9, and you'll notice the equal sign has a black box around it. That means it's going to graph. So in fact, watch this. I'm going to graph this. We don't want to keep graphing those answers. Y equals 3, Y equals -2. That's not helpful for us. So what we want you to do is sit on top of that black box equal sign, press enter, and the black box goes away. Similarly on Y0, sit on top of the Y0 black box on top of the equal sign, press enter, and it turns off the equation. What that means is it's still there, it'll still evaluate, but it won't graph. And if when you're ready for it, to graph it, if ever, just turn it back on. So now when I press graph, it'll be blank because there's no values to be, those are all blank. All right, so back to the home screen, I'm gonna press clear. The next one I want to do is what about for imaginary or complex solutions? Okay. For this one, if there's imaginary complex, you do have to be in complex mode. So we're going to press the mode key and go down to just before full is the word real, like real numbers. Turn right and there's A plus BI. Press enter on A plus BI so that's darkened in right there, A plus BI. So now it's ready to do imaginary numbers. And now go back to the home screen, and we're now going to put in 1 for A, -4 for B, and 13 for C. And by the way, we don't have to put in 1 for A, it's already there. So we'll skip that part. But -4, store alpha apps, enter. So -4 is now in for B. And then 13 store in for C. And it's overriding what was there before. And alpha program gives me the letter C. So 1 was already in there. If you want to type 1 store alpha A, have a great time, but you really don't need to. And so now we're going to evaluate Y9 and Y0. And I already knew those were going to be complex, so that's the reason I had you do that. So again, alpha trace, seems like we've been there an awful lot. Press the number 9 and then enter. And I'm getting 2 plus 3i, which is definitely complex. And I think you can anticipate what Y0 is going to be, but let's go ahead and find it anyway. Alpha trace and get Y0. And it should be 2 minus 3i, it's complex conjugate. So let me stop. I've been doing an awful lot of talking and have no positive or negative feedback. So what can I do to help anybody?
That was exactly what I needed.
Okay, correct, good. Okay. Okay. All right. So while we're talking about complex numbers, let me tell you that the calculator will do complex number arithmetic, which amazes me because on the ACT and SAT, it asks you to do complex arithmetic and they let you to use the calculator. So, and by the way, you don't have to be in A+BI mode either. Okay, to do this. So to prove that to you, I'm going to go back to mode and go down to real and press enter on real. Okay, press enter on real. Again, if you're in A+BI mode, it will work. I just want to prove to you it doesn't have to be. Okay. All right, so let's go ahead and look at maybe the powers of I. Okay. So now I is not the, I'm going to press clear, by the way, to clear this out. Now the letter I, the green letter I is not the imaginary I. The imaginary I is above the decimal point and it's in blue. So second decimal point gets me I. And then I'll square it and hopefully we'll get -1. And we're getting -1 plus 0i. So it's showing you that A+BI mode, which hopefully isn't offending anybody. And then I can do I cubed by again doing second decimal point. And there's two ways to get the cubed. You can do the caret 3, but my favorite always for the cubic is math 3, because math 3 is also the cube. Either way. And then I to the 4th, second I, and then this one I do have to do caret 4, meaning I to the 4th power. And what I would want my students to do is to go through and list these and do I to the 5th, I to the 6th, and have them decide, oh, you know what, it's I, -1, negative I, 1, I, negative, you know, they start to see that pattern, how it's cyclic, and, you know, learn by using the calculator, okay?
So Tom, I'm going to stop you for a minute because I put mine in the real mode, but whenever I was doing that, it just came up. Oh, I just shut my computer off. When I did like I to the 4th, it just showed regular +1 instead of +0i.
Are you using this, the CE or regular?
Yes, I am.
Okay, so
Yeah, the plus.
so under mode, are you under math print? So go to mode, the top, are you
I
math?
am. Yeah.
You math print?
Mm-hmm.
Okay, so one other thing I'll check. Press second plus sign for memory, second plus sign,
Okay.
and press enter. And what is your number? Are you 5.6?
I'm 5.4.
There, that might be why. So your calculator,
Okay.
even though you might have just gotten it, you know, it updated the operating system since then. So
Okay.
it's an easy fix. We'll talk about that later.
Gotcha. No big deal.
Okay.
Okay. I was just curious if I'd messed something else up. Thank you.
No, you didn't. No, you didn't. All right. Also on complex arithmetic here, you can do things like 3 minus 5i, the quantity squared. And this could be this is like a problem that's on the ACT, and you're allowed to use the calculator. It doesn't make any sense to me that it's on there, but I think you should be aware, and so should your students. So 3 minus 5 second I, right parentheses, a quantity squared. Now it doesn't show you how to get the answer, it just gets it. But that's kind of pretty cool. Okay, that will do that. It'll multiply them, add them, divide them, whatever. And then for this one, I'm going to go real quickly on this. You don't need to do it. I just want to show you that it can be done. If I do the fraction template and do 2 minus I over 4 plus 5i, and then press enter, look at how beautiful that is. Okay. Does all that, multiplying by 4 minus 5i over 4 minus 5i, does all the calculations, nice fractions, no decimals, whole deal. So be aware of complex number arithmetic. So I think we lost our science teacher. Is the science teacher still here? Is the chemistry teacher still here? Yes? No? Okay, so I'm going to bypass this then, but you could actually type this into your calculator and evaluate this expression with V, T, and A. Okay, so I'm going to bypass that one since we don't have any science teachers right now. All right, next thing is a little bit more about the calculator. These are 4 things here. By the way, if you need a break, just go take a break. I don't need a break. I'll last until 9:30. And if you need to leave early, I understand that too. But I do need to do this whole thing because it's going to be online for people to watch at their leisure. So if you go back to the calculator and let's press clear and y equals, and again, notice we still have the quadratic formula there, and it'll be there until I get rid of it or update my calculator. This time what I'd like to do is press second zoom, which is format. Second zoom, which is format. And at the bottom of that, it says detect asymptotes. I'd like you, if it's not on, I'd like you to turn that on. The quickest way to get to the bottom, by the way, is not to arrow down, but to press up because it goes like in a circle. So press up and it'll go to the bottom. Press enter on. Okay. And now go back to y equals, let's just do x squared. Y equals x squared. Just type in y1 equals x squared. And then press graph. And it seemed okay. But if you go back and turn that detect asymptotes off, it will graph faster. So detect asymptotes now off, press graph, and it should be, and now it's milliseconds, but it's faster. Okay. Now let me explain why, what it's doing there. Remember when we did that, the first one, and sometimes it had an asymptote, sometimes it didn't. Teachers had said to TI, we don't like that the calculator draws in asymptotes sometimes. How do you turn that off? And so this is how you turn it off. You say, turn on detect asymptotes on. If it has an asymptote, it won't draw it. But if you turn it off, it will draw it. Now, the thing is, if you turn it on, every single time it goes to plot a point, it's going to say, is this an asymptote? So it slows the graphing down. So if you don't care about the asymptote part, first thing I'd suggest you do is turn that off. Otherwise, your graphs are going to be slow and you're going to be angry. Okay. So detect asymptotes off. So now that we've got that off, let's go back to y equals and let's type in these 2 equations and clear out what's in y1. 6 minus x squared is what I have listed there. Enter. And 2x plus 1. Enter. So that's what I've got typed in there. And I'm going to go ahead and do a zoom 6, which is zoom standard, which I think already was in, but just to double check. Now, what I'd like is I would really like to see a grid. Okay. And since the color one allows you to have a grid, we're going to use that. So to turn on the grid, it's second zoom, which is format. Second followed by zoom, which is format. Go down 2 to grid off and make a right turn, go to grid line. Make sure you press enter on grid line. Okay. Now press graph. And we have a grid, but what's not so good about the grid is that these aren't squares. And it would be better if they were squares because that's how graph paper is, they're squares. And the reason why they're not is if you look at the window says X is going from -10 to 10 in steps of 1. Y is going from -10 to 10 in steps of 1. but it's wider than it is taller. And so that's just not going to work. Okay. So what I'd like to do is make this a square window. And the next part I'm going to do, if you don't follow along, it's okay. I'll get you to the end. But what I'd like you to do is press zoom and then do number 5, zoom square. Zoom number 5, zoom square. And you can see that the axes, or I'm sorry, the grid lines are squares, which is great. In fact, let's look at the window to see what that looks like. Except for that decimal, it looks like -16 to 16, -10 to 10. So any window that's in the right proportion 16 to 10 will be a square window. 8 to 5 will be a square window. Okay. In fact, just watch. Don't do, just watch. So I'm going 8 to 5. Okay. -8 to 8, 5 to -5. If I do that, you can see that's a nice square window. Okay. And it turns out that my favorite window is between those two. So if you would press window, and halfway between 8 and 16 is 12. So I'm going to go -12 to 12. And again, you don't have to worry about why this works in steps of 1. And halfway between 5 and 10 is 7.5. So -7.5 to 7.5. And this is like my favorite window. Let me pull that off so you can see it. Make sure you do this because we're going to store this into the calculator and get it anytime we want. So X min -12, X max +12, X scale 1, and then -7.5 to 7.5 in steps of 1. So let's go ahead and see what that looks like when we press graph. And hopefully you'll agree that's a thing of beauty. Okay, it's nice and square, not too big, not too small. You can see things really, really well. Okay. Now, I like this window so much that I'm going to store it so that I can recall it instantly at any time. You can store one graph window settings in your calculator. And again, this is a little known thing for some reason. I think everybody should know this. Okay. So the way you do this is press zoom, and we're going to go over to the right to the word memory. And somebody said, I've never been there before. That's okay. And we're going to do number 3, zoom. I'm sorry, it's number 2, my fault. Number 2, zoom store, meaning take whatever's in your window and store it in this little mailbox here so I can use it anytime I want. So number 2, zoom store. And it doesn't look like it did anything, but it did. So to show you how that works, press zoom 6. Remember that zoom standard where it's kind of messed up? We can get ours back by pressing zoom, going to the right memory, only now don't press 2, press 3 to recall that memory. And there's that window, okay, -12 to 12, -7.5 to 7.5. So it doesn't have to be that to be your favorite window. It can be anything. I know when I teach trig, I like to put in like -pi/2 to 2pi and so on. So okay, I see a couple people had to leave, and I understand that. I'm glad you appreciated it. Hope you can watch the rest of it at your leisure. All right, any questions or comments for those of you still here? Because there's only a couple of you, so you're.
I don't have questions right now.
Okay.
My whole brain is thinking, how do I teach this? I feel like I need to teach it with paper and pencil first, and then, but that's probably not what this presentation is about. I'm trying to think logistically, how do I fit it all together?
So you just do this in context. When you need to be graphing, see if you're going to be graphing, let's say, tell them we're going to use this window and we're going to store it in here so we have it anytime we want it. And we're going to put grid lines on, so if you're talking about the technology. if you're talking about other things, my goal is for students to be able to solve things paper and pencil. Calculator just helps them to visualize it better. right,
Yeah,
so-
the visualization piece of this is amazing.
Yeah, right. That's the key. Yeah. All right. So let me go ahead and continue this. Let's go ahead and look at coordinates of intersection. Okay. So if I look at this, I want to find, I probably can just see what the coordinates are, but this does have a way of finding the points of intersection by using second trace, which is calculate. So second trace is the calculate menu, and number 5 is intersect. So I'm going to find the intersection. Okay, so I'm going to press number 5. And it says, what's the first curve? And I press enter. Then it jumps to the other curve. I'm going to press enter. And the reason for that is there was more than 2 curves. I'd have to pick which 2 I'm going to find the intersection of. Now, my guess right now, my guess is at 0. So it's going to give me the point of intersection that's closer to x equals 0. And that would be this one right here. So I'm going to go ahead and press enter. And there's my point of intersection. And it looks like it wasn't a very nice number, which is fine with me. Very ugly number, in fact. Okay. But here's what I'd like to do. Maybe I need this value of x to solve some problem. Maybe that was some value that's going to help me solve some applied problem. So what I'd like to do is get that value of x without having to write it down. Okay. So let me show you another thing that not many people know about for some reason, but we'll tell you is see those values for x and y? I'm going to go off the home screen, second mode, which is quit. I'm going to press the X key and press enter, and you'll notice that's the value of x that was the point of intersection. So what I'm going to do is I'm going to store that into some other letter that I hardly ever use, alpha tangent for the letter G, so that if that x changes, I still have that x value. And also if I press alpha 1, I'll get the y variable, press enter, and that's that y coordinate that I had. And I'm going to store that into alpha caret, which is the letter H, so that I now have the coordinates in G comma H of the points of intersection. I'm going to do this again. So if I went too fast, I'm going to find the other point of intersection. So don't despair. Okay, I will do this again. So let's go ahead and find the other point, the coordinates of the other point of intersection. So back to the graph. Okay, back to the graph. Press second trace, which is calculate. Number 5 for intersect. And first curve, enter. Second curve is the red one, enter. Only now my guess, if I press enter now, it's going to give me the same point. So I'm going to guess the one that's like closer to -5. So I'm just going to type -5 and say, I want the one that's closest to x equals -5. I could have said x equals -4, x equals -3, whatever. X equals -10, press enter. And here are the points of intersection for that one. And notice they are different. And if I wanted to keep track of them, again, I go off to the home screen and type in x, store alpha tangent for the letter G. And now that point is, the number is now overwrites what I had before. All right, so you always trace to the intersection point. Yeah, and sometimes you don't get there, like you wouldn't get exactly at that number. So using intersect, and then also I like the idea that it stores them at x and y. Now, the reason why I want to put those in other values is I want to show you something here. Just watch. So I'm going to go ahead and graph y equals 3 equals 5. Just watch. You don't have to do this. Okay. Now, remember those values for x and y that we had? When I go off to the home screen now, when I type in x, X is now going to have the value 12, and Y is going to have the value 3, or 5 rather, okay? And the reason for that is when you go to the graph screen, it comes back with the last value for X and Y, and that wasn't the points of intersection anymore. So that's why you want to be careful not storing values into X and Y, because they can change. All right, the fraction templates are here. I don't want to spend too much time on them. These are more middle school, but if you do teach middle school, you might want to use them. So I'll press the clear key. Alpha Y equals, if I wanted to, let's say, add two fractions. So I'm going to go enter on this and type in, say, 2/3. Now, before I press plus, I have to press the right arrow to get out from the denominator. Plus, and then I'm going to do alpha xt theta n to get the other fraction template. Let's say 3/4. So I have 2/3 plus 3/4. If I press enter, it gives me a fraction. Let's say I want that as a mixed number. Notice the third one rewrites from a mixed number. So I'm going to do alpha y equals and press number 3 and say, go from one to the other. And then if I press enter again, it'll go back. Also, if I wanted to change to a decimal, alpha y equals number 4 goes from fraction to decimal and decimal to fraction. And I would say just play with those. Okay, just play with those. Not now, but sometime if you want to use those. But really nice to have those fraction keys, templates. So we also have some other templates that are very nice. I'm not sure exactly what all of you teach, but if you bring up the calculator here, I'm going to press clear to clear that home screen. Alpha window, alpha followed by window, the F2 key has all of these math templates, pretty print. And so if you want absolute value, you could just press enter, and there's your absolute value of -3, enter. And I know some of you used to use absolute value with second catalog, was the first thing in the catalog. So you could still do it, okay? Logarithms are usually some things that people want to do. So if I go to alpha window and look at number 5, notice we can now have logs with different bases other than 10 and e. So if I wanted log base 2, right arrow of 32, 5, and this used to be a question that I let kids use the calculator for. And so now when I would test, I would tell them no calculator on this part of the test. And how I would do that is when I wanted them to use a calculator, the papers were green for green go calculator and white for no calculator. Okay, so this would be now a no calculator question. So we have, you can do derivatives, integrals, all these things. I'll let you play with those when you want to, but be aware that they're there. Okay. I'm going to skip radians and degrees. It's not that big of a deal as some of the other things are. But this one is a biggie, I think. How to solve system of equations using the Polysimultaneous 2 app. This is, to me, is a huge deal. Also, on the ACT, they'll ask you to solve a system, and the calculator has a built-in for this. Not that I want them to use it, but if they have that advantage and they know it's there, let's use it. So for this one here, I'm going to go to apps. And on mine, it's number 9. I'm not sure what number it is on yours, but it's shorthand for Polysimultaneous 2. There used to be a Polysimultaneous 1. The reason why those look so bad is that at most characters you can have is 8 in the name of an app. Okay, so that's why they're a little bit hard to read. So I'm going to press enter on this. And up pops this menu. And we don't want to do the root finder. We want to do number 2, the simultaneous equation solver. So either go down to 2 and press enter, or press the number 2. And notice we can solve equations from a system of 2 by 2s all the way up to 10 by 10. Wow. Okay. That is just amazing. Okay. So if you're not at 2 by 2, make sure you go to 2 and press enter, go to the other 2, press enter, so that you're getting 2 equations with 2 unknowns. You'll notice along the bottom here, we have some words above these hotkeys. If I wanted to go to the main menu, I'd press Y equals. If I wanted help, I'd press trace. I want to go to the next screen, so I'm going to press graph to go to the next screen. And now it's ready for me to type in that equation, those numbers. And we only type in the coefficients and the minus and plus signs. So I'm going to type in a 5 and then enter. Since I already have a minus, I can just press enter, or I could press the minus sign and press enter, either way. 7, enter. 13, enter. Notice when I press enter again, it does take me where I would want to go. And I'll pause just for a minute in case I'm going too fast. Double check and make sure, before you get out of there, that this is correct. So 8, enter, plus enter, 6, enter, -3, enter. And this should look exactly like what I want. Let me double check before I do anything else. So it looks pretty good. And so to solve this, I'm going to go ahead and press the graph key, because that's what solve is above. So I'm going to press the graph key. And there are my solutions instantly. Okay, instantly. And I know some of you are thinking, well, those were my 2 solutions I would have guessed. Okay, which of course ridiculous, but anyway. So those are our solutions there. Okay. And so look how powerful this is. So for me, I would want to use this when their solutions aren't awful, like on an applied problem and the solutions are not nice. Okay. But I still want my students to be able to solve these by hand. No doubt. Okay. So I'm also really big on having them check. Okay. So by the way, if you wanted to see these as decimals, notice F to D is the graph key. So if you want to see them as decimals, which I don't, I'll put them back. But I do want to go back to the main menu to get out of this app. So I'm going to press the Y equals, and I'm going to press the number 6 to quit the app. Okay. So now I'm just going to show you how this is, and I really encourage you to have students check their solutions, especially when they're this odd. Okay. So I cleared this out. I'm going to store 5786 in for X. So I'm going to create the fraction template. 57 over 86. Right arrow to get out from the denominator, 5786. Press the stow key or store key. And I am going to use X because I'm not going to graph anything. So I'm going to type in just for X. Now X has that value. For Y, I'm going to start with the negative sign and then the fraction template. I could have also done -119 over 86, just showing you could do it either way. Again, get out from the denominator. Press the stow key and press alpha 1 for the Y value, Y coordinate. And so now those are the values. And this is the part that I love, because when I ask students, how do you know these are correct answers? Here are their options. So you just say, these are the answers in the back of the book, or this is what Sally got and Sally never gets them wrong. Okay. They don't realize that these are the only numbers in the entire universe that make both of these equations true at the same time. And I'd like them to see that. Okay. And doing this by hand would be awful. So what I'm going to do is have them type in the left-hand side of this equation, 5x minus 7 alpha 1 for Y. I'll wait till you get caught up. While you're doing that, make sure they realize they're going to take the current values of X and Y, plug them in, multiply by 5, multiply by 7, subtract, and they better get what number? Yep, 13, which means that ordered pair works in the first equation. It also has to work in the second equation. So we'll type in the left-hand side, 8x plus 6 alpha Y. Again, take these values, plug them in, do the multiplication, addition, and so on, and This is the only ordered pair in the entire universe that works, and it shows that it checks. And this is powerful to have your students see this. Does anybody like that besides me, or am I the only one that liked that one?
I love it. I love it.
Well, good.
Very cool.
Okay. So again, keep in mind, you can do 2 by 2, 3 by 3. You can even do things like 3 equations, 4 unknowns, 4 equations, 3, and I mean, it'll do any possibilities with infinite solutions, no solutions. Very powerful, very powerful. Okay, thanks for hanging in there. Okay. So the software emulator tips, we're not getting anywhere near what I wanted to get to, but that's okay. Okay. I do want to show you how to use this emulator software, because hopefully you're seeing the advantage just by how I'm teaching you, how important it is for me to have this, or for you to have this, showing your teachers how to use the calculator, or have your students rather, how to use the calculator. So when you can, I'd like you to go ahead and try this emulator software. The first thing that I've been doing all night that I really like is whatever I have on my screen, I can, if I have, let's say, Word open. In fact, let me just go ahead and open Word to just show you this works also with Word. So now I have Word open, and let's say that I'm going to use this to create some kind of a worksheet. So I've got Word open. I'm going to left click on the graph screen, pull it off, drag and drop, and now it's in my Word document. I can format it. I can resize it. I can move it around. So now I can go ahead and create worksheets really nicely with this. So I love it from that standpoint. From the teaching standpoint, if I was doing this with students, I'd say, okay, students, these are the equations that should be in y equals, pull them off. I've got students that are still looking for their calculators. I'll say, this is the window that I want you to have. So I'll pull that off. So the kids that are still looking for their calculators, when they get them, still have a chance to catch up. And I'll say, and this is what the graph should look like when I'm done. Okay. So every time I would do something on a screen, I would pull that off and put it into whatever I'm using for my display. Okay. So I use for my Canvas is Smart Notebook. Even though I don't have a smart board at my house, this is still my favorite thing to use for teaching. Okay. So that's one of my favorite features for that. Other things that, oh, by the way, there is a PDF of all the things you can do with Smart View that I created that have screenshots. So if there are things that I went too fast, or you want to try some things that I didn't get to, they're in this Smart View primer that you're welcome to use. So I did the drag and drop. We've already done that part. Okay, so always in front. So right now, this is the way I like to teach. I like to have my calculator on the left part of my screen, and then I can go ahead and do my teaching on the right-hand screen. I can do my, 2x minus 3y equals 5. But you'll notice as soon as I started to write, the calculator disappeared, and that gets annoying. So under View, the last one is always in front, meaning always in front of the screen. So I'm going to click on that. And now when I go to write on the screen here, it doesn't disappear because I have this always in front. And so that's an option that you might like or maybe not like. So I'll turn that off. And now when I click away, it's gone. So again, this is under View, always in front. One of the things I do like there. Okay. Another one is something called View Cubed. You can actually see 3 other screens besides your home screen here. Let me show you that. So where I get that is if I hover over this long enough, it'll say hide show view cubed. Okay, and hopefully you can see that over there. Hide show. I'm going to click on that. And so now these 3 things they look blank. What I need to do is click on the refresh button. And so now it's showing graph, window, y equals. And I can actually milk 4 out of this since I already have the graph here. How about if I change this to table? And I've got the table, the window, the equations, the graph, all here for students to see at one time. And they're all pullable. I can pull all of them off, which I love. So if you like that feature, I strongly urge you to use it. Okay. So it's called View Cubed. It really should be called Quad View because it does 4 things instead of 3. The key press history, I will show that. I've never really been a big fan of it, but let me show it to you anyway. So I'll turn this off and turn this on. And this shows you all your key presses. I just find it confusing, but if you think this helps your students, then use it. The one part I do like to use this for is if I'm creating a how-to, I will, let me see if I can make this a little bit smaller. Yeah, there we go. If I want to use the snipping tool, I can use the snipping tool and say, I'd really like to show you what alpha trace looks like. So I can copy, I can, cut them out of there, and then I can put them into a document. Okay. So I do like that feature for that part. Different calculators can be emulated. You can have either the color or the black and white, the grayscale. Okay. And that would be done right here. And if you don't have the I'll do the grayscale, and they're 2 completely different calculators, whichever on one's not on the other. This is supposed to be a ghost. I'm doing a Halloween webinar, and so I had to draw a ghost with functions. So that's why that's there. But then if I want to go back to the color, it's wherever the color one was. So that's a possibility. You can also control the calculator with a handheld. This is my second favorite thing on it. If I'm teaching and I don't want to keep hovering over the computer, okay? I don't know if you heard that little noise there, but I'm going to go ahead and have my calculator run this. So on my calculator, you can't see it, but there's an app called SmartPad. I'm going to run the SmartPad app, okay? The first time you do it, it might take about 30 seconds for a driver to be installed, so be patient. But now that I have it running, so I'm going to press Y equals on my calculator, and it's performing here. And if I press graph, I'm getting the graph, and notice the graph button shows up. And if I press the window, I get the window, all by just pressing the buttons on the calculator. Now, just so you know, this is like a remote control. What is on this calculator itself is not what's being displayed here. This is just being like a remote control on your TV. The programs aren't on your remote control. It's just you were too lazy to press the buttons. So this just presses buttons for us, but I still like it. I really like it is if I get a long enough cable. If I have a student that has too much energy, I'll give the calculator student, have that student run the calculator. That way I can observe the students better and focus on other things. So really like that idea about that. Large screen versus regular calculator. I've been showing that. This is the large screen version, and you can make it as large or as small as you want. Okay. I like this sometimes, but then I can't see what else is going on. By the way, this is pullable. You can pull that off as well. Okay. And that we're getting kind of close to the end here. So I do want to show you the website and what's on the website. I might continue on and show a few other things at the end of this video. So those of you watching the video, I may go on a little bit further, but I do want to let these people go to sleep or whatever it is they need to do at their house. So let me skip ahead here. So this is the website, and this is the link to it. Again, I'll pause just for a minute in case you need to write that down. Lowercase bit.ly/TI 2019, the year you got you should have gotten your award, and then capital PAEMST. Okay, so if you go to that website, this is what it looks like, and I created that for you. The very first, and you don't have to go there now, you can just watch. The very first link is 17 videos. of some of the tips and tricks we did tonight, and some I didn't get to. Okay, so for example, evaluate expressions in one variable. That's what we started with. Function composition, poor person's quadratic formula. Okay, what we didn't get to do is transformations with lists. We didn't get to do finance app, transformation app, and some of these things here, which I will do a little bit later in the video for those of you who want to continue watching. But that's one link, and what you can do is you click on the video and it'll show you the video from YouTube, which unfortunately is me again. Okay.
Hi, this is
Okay.
Tom.
But if you click on this, it'll just show you a PDF with step-by-step screenshots on how to do these things. And you might like that better than the video. Okay, so I'm trying to make it as easy as possible for you to learn how to use your calculator and use it as effectively and as creatively as possible. So that's the first link, is this tips and tricks. Tomorrow I will put the PDF of this presentation, because I need to go back and fix those screenshots, but I'll have a PDF to that in case you want to look at it again. The video of the presentation will be linked here as well. Okay. So if you want to share it with anybody, by the way, you're welcome to share this website with any of your colleagues. It's fine if you think it's worthwhile. There are a couple other things that I do want you to be aware of. Families of functions. This is a website that I created during COVID. It has over 250 videos on how to graph the parent functions and compositions of, or I'm sorry, lost my word, transformations of them. And these are the different transformations it does. The main thing I'd like you to do is to download the quick reference guide, because if you download the quick reference guide and open it, it has links to all the videos. And this, you could give this to your students and say, you know, here are some linear functions. If there are any, so here's the example, here's the now you try one. If you don't know how to graph this, play this video, it'll show you how to do it. If you don't know how to graph these linear functions, play the video. If you need to learn about slope, this explains how to do slope. Quadratics, okay, let's say you're not sure how to graph this one, just play this video. But it goes on and on, absolute value, square root, and so on. So these are all available to you. They're on the TI website. This was my COVID project. I have over 500 hours creating them. I'm hoping people can use them. Yeah, it was a lot of work, but fortunately TI has been generous to let me work for them for that. Other things on there is a thing I just created is I got to do this with my kids' website. And this came out of just a conversation I was having with one of my colleagues. And I said, I wish I could get students to do this. And so these are 25 different activities, and I guess, 26 different activities on clever ways to use the calculator. Each video is 2 minutes or less, so they are very quick, okay? And each video has a student PDF that goes along with it, okay, that the students can use. And each one has a teacher PDF that has the notes and solutions. So this is really more for teachers to be able to learn how to teach their students. Again, please pass this along. They were a lot of fun to make, and hopefully I've heard good things about them, but just trying to get people to use them. This is TI's website, education.ti.com, okay, for anything TI. And if you have any problems with tech support, this is the number 1-800-TI-CARES. But this is the actual number if you're not sure about that. So let me see if you have any questions or comments. I am going to continue the video, even though you're probably not going to be on, because there are a few other things I wanted to show, and you're welcome to watch it later. But any final questions or comments, anything I can do there? Yeah, no, you don't need to stay. No, you don't need to stay. I realized I told you 9:30. That's fine.
This was great. Thank you. I got a lot out of it. I'll have to go back and test everything out again, but I think it was really worthwhile.
Well, good. I'm glad to hear that. And I hope people feel that, watch it online too. So have a good evening. Thanks for
I
coming.
would love to use this video with my teaching math team, because we all use the TI-84s. I just opened new ones today that we got. This was so helpful for me with my algebra students. Thank you.
Well, good. And you're welcome to pass the website along to anybody. They're allowed to use even though this is for presidential awardees, anybody can use the website and the videos.
That's awesome. Thank you.
All right. Well, have a good night. And I'm gonna continue here talking to myself. So have a good night. Okay, so if you are willing to stay with me, I am going to show a couple other things on here that I thought would be worthwhile. Here we did the view cube. Let me see what we left out. Transformations with lists. Okay, so I do think this is kind of a cool thing, transformations with lists. So I'm going to go ahead and go to Stat Edit. And I'm going to clear out what's there in the list. And you notice I'm going faster because I don't have anybody to stop me. So you're going to need to pause the video every once in a while. So I'm going to go ahead and put these numbers into list 1, -3, -2, -1, 0, 1, 2, and 3. And if you are going along with me, go ahead and pause. Okay. And what I'm going to do is I'm going to go to y equals, and I'm going to clear all that's in y equals. And you know what? I think I'll go ahead and pull that list off so people can see it. So this is what is in list 1. Okay. And I'm going to go to y equals, and I'm going to type in x squared plus list 1 into y1. So x squared plus second L1. And in y2, I'm going to type in just plain old x squared, which is the parent function. All right. So let me pull that off as well. All right. And now what I'm going to do is I'm going to go ahead and make my windows the window I like. I'm going to go ahead and press graph, and we'll see what you think about this graph. And what it end up doing is graphing the family of curves y equals x squared plus a constant. Hello, somebody just came in. We actually finished at 9:30. I'm just adding a few things. You're welcome to stay. Ruth, I guess your name is Ruth. Hello, you can unmute. Because I'm just finishing the video for to put online. So you're welcome to stay. So that shows that family of curves. If I go back and change this to the quantity of x minus second list 1, the quantity squared, watch what happens when I graph this. Well, let me put that in there and graph that. And now it's showing the horizontal shifts, okay, and comparing it to the parent function y equals x squared. And then I also can clear this out and do second list 1 times x squared. And hopefully you can anticipate what's happening there. It's a family of functions of the dilations there. And you could do this with any function. It doesn't have to be x squared. And it's just a quick review of how the different parameters affect the graphs. So I do like that. That's with lists. But we also have a transformation app, which I think is really cool. Okay. And so let's go ahead and look at the transformation app. So the transformation app, I'm going to clear out what's there. And it's an app, and it's the last one. So I'll press the up arrow to get to the last one. and run the transformation app, press any key, well, any key. And when I go to y equals, you'll notice something different about what's next to y1 and y2, a little bit different looking feature, meaning those are the ones that can be done with transformations. So I'm going to go ahead and type into y1 x x squared plus alpha c. And in y2, I'm going to put the parent function because I always like to compare to the parent function, okay? And now when I graph it, notice it says c equals 13 because that's what we had, c equals 13. So I'm going to type 0 for c and have it start at 0. And now watch what happens when I press the right arrow. C is going to increase to 1. And so I'm graphing x squared plus 1, c equals 2, x squared plus 2, x squared plus 3. Then I can go down to the left. And if I'm in a hurry, say, oh, I could get to -6 real quickly. So just type -6 for c, and it'll go there. And so now I can go ahead and play with the vertical transformations. I can also do the horizontal transformations by the quantity of x minus alpha b, the quantity squared. And here when I go to graph, my value for b was -4 when we did this before, so I'll just start at 0 again. And again, left increases the value of the parameter, x minus 1, the quantity squared, x minus 2, the quantity squared, and left arrow decreases the value of b. And again, if I'm in a hurry, I'd like to go to 5. It'll take me right there to 5. And notice it says right here that I can have up to 4 different parameters, which is plenty for, I think, high school math. So let's go ahead and do one with 3 parameters. Alpha A times the quantity of x minus alpha b, the quantity squared, plus alpha c. And again, I always like to have the parent function there. I'm not sure what a, b, and c are, so I'll go ahead and press graph. And it looks like a is 1, b is 5, c is -6. So it's graphed 1 times the quantity x minus 5 squared minus or plus -6 or -6. Okay. So if I wanted to say change the value of c, I would go down to c and then maybe type in 0. So it starts at 0 and press enter. Go down to b and make that 0. So I'm starting clean here. And so you can see up and down takes you in between the parameters, left and right decreases and increases the value of the parameters. So right now, if I wanted to just concentrate on A, I'll go up to A and now press the right arrow to increase A to 2, to 3, to 4. And then I can go left to decrease. And when I go to 1, it melds right into the x squared. 0, x squared is linear, the opposite of x squared, and so on. And if I want to, I could even type in, like, let's say 0.5 and have it go so I can see 1/2 x squared and see what's going there. And then when I increase, it'll go by still the ones. Okay. So now I have 1.5 and 2.5 and so on. But let's make that a 1 again. And then I can go to B and move B around. I can go to C and move C around. Okay. But transformation app works not just with x squared, but any parent function that you would like, anyone. I know I'm going pretty quickly, so I'm hoping you'll pause me if you need to. Graph that equation or equation that graph. Another one of my more favorite things to do. So now whenever you use an app, the first thing you want to do is turn it off when you're done. So I'm going to go back to the transformation app. And when I try to run it, I don't want to continue. I'm going to do number 2, quit the transformation app. And when I go to y equals, I can see that I have quit it, okay, because those funny looking things are not there anymore, okay. So let me go ahead and clear these. So what I'd like to do is I want to model curves with equations. And so the calculator comes with pictures in it. And here's how you put those in it. Second zoom, which is format. Up arrow twice to go to background. And there are 10 pictures in here. I have different ones than you may have. But on number 4 is a drinking fountain. But we don't see a drinking fountain. We see an upside down parabola. So we're going to have that be our background. And when I press graph, that is now my background. And so what I want students to do is come up with an equation that models that and put it right on top of it. Okay. And so like I'd have them say, well, how about the first, how about we try y equals the opposite of x squared? How does that look? And say, hey, you know, that's not a bad idea. It's a good start, but it looks like I need to move it up 1, 2, 3, 4, 5, 6.5. So we know what that means. That means it's going to be the opposite of x squared plus 6.5. And I'm going to graph that one. And that looks pretty good. Okay. But now I have to move it to the left 1.5. And I'm going to do what students do in my classroom, probably not in yours, but in mine. Negative the quantity of x minus 1.5, the quantity squared. They goof that up sometimes. But what I like about this is the calculator will tell them they're wrong. Okay. And they can see, oh no, it went to the right, not to the left. So it helps them figure out their errors. So I'm going to go now change that to a plus 1.5. And yeah, it's moved it over pretty well. And now I need to just make the dilation factor wider. So how about if we go with like a -0? And I know the answer, so I would really be doing this by guess and check. But look at all the transformation graphing that's being accomplished here. And the students are finding out immediate feedback where they're correct or not. So now you can see that I've pretty much nailed it. Okay, pretty much nailed it. And you can get other pictures in here. So for example, other pictures, other images that you could use. You could do absolute values in this leaf. You could do parallel lines from this playground. I have some others on here. I have a pumpkin. I'm going to be doing some pumpkin things for a webinar. I did the Green Bay Packers, another ghost. I did a football thing. So you got a lot of different things, and you can bring in your own pictures or use the ones that are at TI. Okay. So model with curves is a really cool thing. The last thing I think I'll do is graphing piecewise functions, and because I think that's important. There are other things that I would like to do with you, but I think this is plenty. So I'll go to y equals and clear all of these guys out. And I'm going to go to y1. I'm going to make a real simple piecewise function. Piecewise functions under math, and then press the up arrow because it's the second of the last thing on math piecewise. And when I press enter, I can go up to 5 pieces or down to 1, like a limited domain. Let's do 3. So I'll go to 3 and press enter twice. And it puts in just like you would see in a textbook. And I'm going to make this really simple. I don't want to make this complicated. So how about if we go with, say, -1 for this function, right arrow, when x is less than -5. So under second, math is where the inequality signs are. And number 5 is less than, strictly less than -5. Notice that's right arrow to get to the next one. Let's just go with the line y equals x. And let's have this go between -5 and maybe +3 inclusive. So I'll type in the -5. Oh, not -2, we're -5. Second math, which is test. And I could do the inequality, but if you go 2 to the right, conditions, they have these ones already templated out for me. And I love the 5th one. So I'll just press 5 and it says -5 is less than or equal to x, and x is less than or equal to, what did I say, 3. And then finally, how about I'll go with maybe 4 when x is greater than 3. So x, second math, and strictly greater than 3. And when I press graph, ooh, I don't like the fact that it has these jerky things to it. So this is one of the few times when I go to second Zoom and do detect asymptotes on, so we don't get that jerky thing going on. So detect asymptotes on, graph, and now it's a piecewise function, just like you would want it to look. So this again is something you might want to play around with, but really like the piecewise functions. All right, we're not going to do the finance app. We just pretty much, those things are on the other website. So again, I encourage you to go to the website, to share this with your students, share it with other teachers. I'll have this, the PDF and the video linked hopefully by tomorrow. You have my email address. Please contact me anytime. And don't be afraid, if you have any problems with tech, call 1-800-TI-CARES. They are great. So thanks for sticking with me. Have a good school year.